The activity that we're going to do to review the law of conservation momentum in 2 dimensions is going to be in its most basic form. Something that looks like this. 2 objects, 2 softballs or 2 hockey balls, colliding at 90 degrees or something fairly close to 90 degrees. We'll call this one object number 1, we'll call this one object number 2. Object number 2 will be going this way, object number 1 will be going this way. There's going to be a collision point right here where they hit each other. And because there's no Velcro or anything like that attached to it, they're going to bounce off of each other and go off something like this. Because we're going to use softballs or some other kind of ball, there's not going to be a lot of friction involved here. We're going to have fairly close to an isolated system. It's not going to be perfect, but it's going to be fairly close to an isolated system, which, as you remember, is a system. Either matter or energy come in or out. In other words, it's little forces, not much. These are little forces. But how exactly are we going to collect the data from this? If we've got softballs rolling on the floor, how are we going to measure the velocity of the softballs as they roll on the floor? Well, the first thing you're going to do is video. You're going to video with your iPhone. My suggestion for that, when you're using your iPhone, the iPhone needs to be held really, really steady. So the easiest way to hold it steady is not to put it in your hand and aim it at the event that's taking place below, but rather put it on your desk like this. Have it hanging over the edge of it, and the camera hanging over the edge of it. Hold on to it so it doesn't fall off. Record the event that's taking place down on the floor as they're holding on your iPhone. It's a lot less likely to be jerky when you do that. That makes sense. Once you get that video recorded, which, by the way, will include 3 things. Ball number 1, ball number 2, and a meter stick. It doesn't matter what the meter stick is. There'll be a meter stick in there. I'll tell you the reason for the meter stick in the ball number 1, ball number 2, the meter stick. Just make sure, it doesn't matter what the meter stick is, just make sure that it doesn't get in the way of the motion of the balls. That's all. Maybe we don't want the balls to hit the meter stick to be affected by that because some of them are isolated system. All right. So we video it, and then what we're going to do is upload that video to somebody's, whoever has the phone, their Google Drive, and then as a group, you're going to examine that video with a program called Tracker. That's the program that's installed on some laptops that we have in the back room. It's not installed on the Chromebooks because it doesn't work on Chrome OS. It only works on Windows. We're going to use laptops tomorrow in order to analyze that. We use the Chromebook perhaps to write some stuff up, but you're going to use the laptops in order to actually collect the data. So once you've got this video uploaded to Google Drive, you're going to log onto the computer, and then you're going to download it from your Google Drive computer to the desktop of the laptop. That's going to allow you to open that video in the software program again that we call Tracker. To open it, you're going to simply go this little button up here in the top left-hand corner, and you're going to find it wherever it is stored on the desktop. So I've got a folder on the laptop. After you've opened it, you should actually physically see the video in the big screen. There's a number of steps that we have to do here in order to analyze this now. The first thing we have to do is to click on this little button that's underneath its coordinate system. Click on this little button right here that looks like this. Axis. That creates a frame of reference for us. It doesn't matter where you place that frame of reference. And when you click on that, right click here, it's going to put the XY axis here. Wherever you put that, it's okay. Your frame of reference doesn't really matter where the frame of reference is. As long as it's consistent with the kind of like, look, unit 1, we had a question about the worksheet. We wanted to find the velocity of a gun after the fire relative to the train that was moving, right? We could have analyzed that problem relative to the train, but we could have also analyzed that problem relative to the ground. It doesn't really matter to me. Once we make our frame of reference in the same place, throughout the whole experiment here, it doesn't matter what that frame of reference is. So, put it wherever you want. Put it wherever you want. Just make sure that it doesn't change. Then you're going to click on this tracks button. It appears at the top left. It goes way up to the side for the system. You're going to click on New. You're going to click on Calibration Tools. And you're going to click on Calibration Sticks. So a menu that wants a sub-menu, and a sub-sub-menu, and then a sub-sub-sub-menu. Ultimately, you're going to get this calibration stick. This calibration stick is a method for the computer to know what year it is. The computer knows how to measure time because it knows the frame rate of the video. It knows how many frames per second are shot, so it can measure time relatively easily. But it can't measure distance. It'll be told what year it is. That's why you can computer stick the original experiment. Notice in my video here, the computer stick on the left side. Notice like four axes. Also on the left-hand side, it doesn't have a way to that. Put it somewhere. The meter stick, just put it out of the way somewhere. So meter stick is going to use in conjunction with the calibration stick in order to tell the computer what it is. So now we put the calibration stick, click on the video, calibration stick, put it anywhere if you want. And you're going to have to drag it with the meter stick. You might have to rotate it so that it matches up. You may, as in my case here, find that you need to get the entire meter stick in the video. If that's the case, then you want to apply not 1 meter, but you want to apply 30 centimeters or 50 centimeters. Whatever you find, make sure you number it corresponds. 30 like I have, then that's fine. If it's 50, even better. If it's 100 centimeters, even better. Just make sure it's consistent with what you're actually doing. Now the computer knows what a meter is. It also knows what a second is. Now it's time to almost to actually analyze that. What we have to do now is to find our data. You only see one of this. Right now. We want to just create a point mass for each of the objects. If I click on the blue button right here, and then point mass is just below that. You can do that twice. Just get objects. If you had 14 objects that we're analyzing, then we do it 14 times. Once you've got the two objects created, one source is created, and all you do is along the bottom, scroll to the point where you just release these objects. And you see the answer here. Just release the ball. Just release the ball. We don't want to analyze before the ball was released. We want to analyze after the ball was released. And then after the position. So scroll down there to the point where the ball is just released. Then you're ready to start collecting data. Click on mass A. Can you do mass A first? You're going to do this for mass B, but one at a time. Click on mass A. Then I want you to hold the shift key. This is kind of weird. Why the mechanism for recording the data set is, I'm not sure, but it is what it is. Hold the shift key. Click on mass. So give a notice up here. Hold the shift key down. It will automatically see forward one frame video. Do the same thing in that frame. It will automatically see forward one frame. That's what 30 frames, 40 frames. That's about how much data you have. Hold the space bar and click one where the ball is. You can stick it from that B. Go back to that B. You can stick it to this before and after. Now we've got. Now we should have a trace of the ball's path. You can see that I don't have a trace of that ball. You'll see something. bottom right hand corner, you see a whole bunch of data. Right now that data is from mass A. Hard to see the axis here. This axis is time, X position, Y position. What you're going to do now is take all that data, select all that data by clicking on it and then clicking Control A, then Control C, and the instructions are there. You go into sheets, clicking Control V, that pastes all that data. Then do it again for mass D. So drop down and select mass D. Control A, Control B, Control sheets, Control A, Control C, Control B. Now you get your data in your spreadsheet. Now you can share that spreadsheet with all the departments so that all of you have access to that. Does that make sense? I know that's quite a video, but you have the instructions in front of you tomorrow, so you don't need to memorize it. Now, what about the analysis? What about what we actually have to do with this data? Well, you're going to have to separate these two tables into 8 tables. You're going to have to convert it into 8 tables. First of all, you're going to have to look at the data for x-axis. You're going to need the data for initial. You're going to have to get object number 2. Initial. 5. Position. You're going to have to get object number 1. Final. So after the group takes place. So object number 2. Final. After the group takes place. So next time. That's all of your next data. You're going to see your Y. 4 tables for the X component. Then your analysis. The analysis consists of graphs. It's better than 21 graphs, so you have your analysis. The 8 graphs attached correspond to 8 tables. So in other words, you're going to get from graphs. You're going to get B1 initial X of 1. 2 initial X of 1. 1 final X of 1. B2 final X of 1. Yeah, 1, 21, so that's 10%, and then it's conserved on the exact more than 10%. Anything goes fine. What do you got to hand in for this? 8 data tables. Sure, down your mass 1, mass 2 as well. 8 data tables, M1 and M2, 8 graphs, velocity of those data tables, and then your little analysis down here. See if there is no problem, hypothesis, materials, procedure, variables, any of that stuff. There is no source of errors, source of error. All I want to see is data